Sveiki! Tātad šodien es jums parādīšu, kas ir programma Simulink. Simulink ir simulāciju un modeļu veidošanai bāzēta vide dažādām aktīvām sistēmām, kuras integrētas ar MATLAB. Simulink, kas ir MathWorks veidota programma, ir datu plūsmas grafiskais programmēšanas valodas rīks priekš aktīvu sistēmu modelēšanas un simulēšanas. Principā tas ir grafisks bloku diagrammu rīks ar pielāgojumu daudzumu dažādu bloku funkciju. Tas ļauj tev iekļaut MATLAB algoritmus modeļos, tāpat arī iekļaut simulāciju rezultātus programmā MATLAB tālākai analizēšanai. Simulink atbalsta sistēmu līmeņa dizainus, simulācijas, automātisku kodu ģenerēšanu, iestrādāto sistēmu testēšanu un apstiprināšanu. Eksistē vairāki citi MathWorks izstrādāti third-party produkti, kuri ir pieejami lietošanai kopā ar Simulink. Šajā sarakstā daži zināmākie no tiem: Stateflow Simulink Coder, XPC Target, Embedded Coder, HDL Coder, Sim Events. Simulink ir spējīgs sistemātiski verificēt un apstiprināt modeļus, atpazīstot un pārbaudot tos pēc uzbūves, noteikt prasības modelim un veikt tā vispārīgu analīzi. Simulink dizaina apstiprinātājs ļauj jums identificēt uzbūves kļūdas un ģenerēt testa versiju scenārijus modeļu pārbaudēm. Un arī parādīšu, kā izveidot un simulēt vienkāršu modeli šajā programmā. Tātad vispirms mēs atveram programmu MATLAB, un, lai atvertu Simulink, mums ir komandu lodziņā jāieraksta vārds Simulink. Nospiežam taustiņu Enter, un mums atveras Simulink sākuma lapa. Tātad jāspiež uz New Model from Template. Un tas, ko mēs varam redzēt šeit, ir veidņi, kas dod iespēju jauniem lietotājiem vienkāršāk uzsākt darbu. Tie ir domāti, lai nebūtu modeļa veidnis jāveido pašam no nulles, spiežot blank model. Ja jums ir citas programmas līdzīgas Simulink, ir iespējams izvēlēties citus veidus iesākumam arī priekš šitām programmām, piemēram, Simscape. Šie ir veidņi priekš Simscape un dažādām citām programmām. Bet tagad paskatīsimies, kā uztaisīt savu modeli, spiežot uz blank model, gadījumam, ja mūsu paredzētajam darbam nav atbilstoša veidņa. Spiežam blank model, tagad spiežam create model. Tas izskatās šādi. Pirmā lieta, kas ir jāizdara, ir jāuzspiež uz šī saglabāšanas lociņa un jāsaglabā savus failus. Tātad saglabāsim viņu uz desktopa ar nosaukumu Simulink 1. Tad esam saglabājuši. Un, kad tas ir izdarīts, nākamais solis ir ievietot vairākus blokus mūsu jaunajā modelī. Tā. Atrodam mūsu Simulink library browser, samazinam viņu nedaudz. Un šeit jūs varat redzēt visu veidu blokus, kādi vien ir. Ir sources, jeb avoti, kāda veida signāls ies. Ir arī matemātiskas operācijas, kā moduļi un reizinājumi, dalījumi. Tālāk ir arī atvasinājumi, integrācija. Ļoti plašs spektrs šai programmai ir. Visus šos blokus jūs variet vienkārši ievilkt savā Simulink modelī. Pirmajam piemēram izveidosim vienkāršu modeli. Klikšķinām uz Sources un izvēlamies bloku, kas kalpos kā signāla avots, jeb signal source. atrodam un izvēlamies sine wave un vienkārši ievelkam to Simulink modelī. Šādi. Tagad tiek piedāvāta opcija iestatīt amplitūdu signālam. Var tur vienkārši neko nerakstīt, tad tiks pieņemta amplitūdas standarta vērtība, tas ir 1. Mēs ierakstīsim 2 un nospiedīsim Enter. Tātad amplitūda būs 2. Mēs varam bloku palielināt. Uzspiežot peles rullīti, mēs varam mainīt atrašanās vietu. Virpinot rullīti uz priekšu un atpakaļ mēs varam palielināt pašu bloku, kā viņš izskatās. Tādas ir tās iespējas. Tālāk ir jāievieto bloki, kuri pastiprina vai maina signālu. Lai atrastu sev nepieciešamos blokus ātrāk, var meklēšanas lodziņā, kurš atrodas šeit, ierakstīt bloka nosaukumu. Šajā gadījumā es rakstu gain, jo man ir nepieciešams tieši gain bloks šajam piemēram. Nospiežu Enter, un pats pirmais, ko atrod, ir gain bloks. Simulink commonly used box gain. Jā, tas ir īstais. Es vienkārši ievelku šo bloku iekšā savā modelī, jebkurā brīvajā vietā. Kad tas ir izdarīts, ir jāizvēlas tā vērtība, jo tas ir reizinātājs. Šajā gadījumā mūsu sinusoidam grafikam viņš reizinās amplitūdu. Tātad, ja amplitūdu mēs bijām iesadījuši 2, reizinātājs to pareizinās ar mūsu skaitli, ko mēs tūlīt izvēlēsimies, un amplitūda mainīsies. Tāpēc būs galu galā savādāka līkne. Tātad ierakstīsim 3. Var ierakstīt jebkādu skaitli decimālu daļu. Tas viss strādās. Uzspiežam Enter, palielinam bloku, lai labāk saskatāms. Un, ja gadījumā sanāk nejauši ievadīt nepareizu vērtību, vienmēr var to rediģēt, dubult klikšķinot uz bloka, nomainot vērtību un spiežot Apply, OK. Un vērtība ir nomainījusies. Tagad ātri nomainīsim vērtību atpakaļ, jo mums vajag 3. Tagad, kad mums ir vairāki bloki, tos vajag savienot, un to izdarīt ir vienkārši. Jāuzspiež uz pirmā bloka malas, neatlaižot jāvelk līdz nākamajam blokam, tad jāatlaiž un bloki ir savienoti. Tātad šādi. Uzspiežam un savienojam. Tik vienkārši. Kad bloki ir savienoti, ir nepieciešams pievienot bloku, kurš vizualizēs grafiku. Lai to izdarītu, uzklikšķinam jebkurus baltā laukuma un rakstam Scope. Kad abi bloki ir savienoti, ir nepieciešams pievienot bloku, kurš vizualizēs grafiku. Lai to izdarītu, uzklikšķinam uz meklētāja lodziņa, kur rakstīts Gain, nodzēšam to, un tagad rakstam Scope. Jo tas ir bloks, kas mums ir nepieciešams, lai vizualizētu grafiku. Pats pirmais rezultāts, Simulink commonly used blocks Scope, tas ir īstais. Ievelkam Scope lodziņu iekšā savā modelī, jebkurā brīvā laukumā. Tātad ievelkam viņu šeit. Kad ir parādījies Scope lodziņš, tajā jāievada, cik ieejas portus mēs gribam blokam Scope. Mēs izvēlamies 2, jo gribam redzēt grafiku gan pirms, gan pēc reizinājuma amplitūdē. Tāpēc mēs rakstam 2, nospiežam Enter, palielinam lodziņu un redzam, ka mums ir 2 porti. Kad tas ir izdarīts, savienojam Gain bloku ar Scope bloku, lai rastos grafiks. Tātad kā iepriekš, velkam ar kreiso peles taustiņu un atlaižam šeit. Tagad tie ir savienoti. Lai mēs redzētu arī sine wave grafiku bez pārveidojuma, kāds tas ir oriģināli, mums ar labo peles taustiņu jāuzklikšķina pa vidu līnijai, kas savieno sine wave un gain blokus. Un jāvelk atzarojums no līnijas uz otro ieeju, jeb input scope blokā. Tātad ar labo peles taustiņu uzklikšķinam un velkam līdz šejienai un atlaižam. Un ir savienots, Un tagad Scope mums rādīs divus grafikus. Vienu grafiku pēc reizinātāja un otru grafiku tādu, kāds viņš bija pirms reizinātāja. Kā arī ar kreisopeles taustiņu uzspiežot uz līnijas, var līniju pavilkt, pamainot tās formu. Šādi, jebkuru līniju. Mūsu gadījumā tas neko nemaina, tikai vizualizāciju, bet tā ir ļoti efektīva opcija ērtības ziņā. Tālāk, lai redzētu simulācijas rezultātus, ir ar dubultklikšķi jāuzspiež uz Scope bloka, kas atvērs diagrammas lodziņu. Tātad klikšķinām divas reizes uz Scope bloka. Tas mums atver diagrammas lodziņu. Tālāk ir jānospiež poga Run, kas ir šeit, Simulink rīkoslā. Un lūk, mums parādās grafiks. Šis ir grafiks ar amplitūdu 2, kā varam to redzēt. Lūk šis. Un šis grafiks ir ar amplitūdu 6, tātad 2 reizināts ar 3. Tad viss ir izdarīts pareizi. Tas, principā, ir arī viss, ko gribēju šodien pastāstīt. Es domāju, ka es varētu vienīgi parādīt vēl dažas lietas ērtībai. Ja mēs esam šeit savā modelī, tad uzspiežot taustiņu Space, mums modelis mērogosies tieši cik vien liels var būt, lai visu labi var redzēt. Un, ja mums vajag nomainīt vērtību, mēs varam nomainīt vērtību, dubultklikšķinot, uzspiežot citu vērtību, pieņemsim 7,9 vienalga, apply OK, un vienkārši uzklikšķinam šeit, un grafiks uzreiz atjaunojās. Labi, nomainīsim vērtību atpakaļ uz 3. Vēl ir iespējams diapazonu palielināt vai samazināt. Attiecīgi, ja mēs uzspiežam 5 šeit, mēs uzspiežam uz grafika play vai run, mums pavisam savādāks grafiks. Grafiku var arī pietuvināt, attālināt un ar šo opciju bīdīt. Kā arī, protams, ja var samazināt amplitūdu, var arī palielināt. Var uzlikt, piemēram, 30. Tad grafiks mazliet sakropļojās, bet, ja tas ir nepieciešams, to var izdarīt. Tas arī viss. Paldies par uzmanību. Tātad turpmāk manu iesākto Simulink modeli papildinās un modificēs mani kolēģi no MATLAB, un viņi runās angļu valodā. Jūs varēsiet redzēt, kādas vēl ir MATLAB iespējas un ko tajā var darīt, kā var pamainīt šos grafikus. Tātad skatāmies.
This is a very simple model, but at this stage you're already all set to create your own models. But let's see how to create a somewhat complex model.
Yeah.
So
what are you thinking? Like a plant control model?
A very simple plant control model that using some of the inbuilt blocks instead of building anything from scratch. So let's see how that can be done.
Sounds good. Yeah, it's a pretty common application for Simulink.
Yes. So I'll just shift drag this block. Shift drag meaning holding shift and the keyboard and then dragging it with my mouse so that I can add other blocks. Now, if I don't want this block in my simulation, I can simply delete it. But if I am not sure, I can also comment it out so that I can bring it to my simulation later if I need it.
So it's like commenting out lines of code
right.
in MATLAB. And you can actually see it's a similar indicator there, right?
Yep.
The percentage sign. So it's as if it's deleted from your model.
Exactly. So when I'm running my simulations or generating code later on, this block will be ignored by Simulink altogether.
Right.
But it's just there for my convenience. If I just want to turn it on, it's just a single click. I can uncomment it from right here.
Yeah, it's just the nature of building up models. Everything's not going to be perfect. You're going to want to try new things.
Right.
So, let me try something else, but I might want to go back to this. So let me drag this off to the side, comment it out, and maybe I'll refer back to it later.
Yeah. So let me bring in some additional blocks here. I can bring in a plant model, which is essentially a transfer function. As I search for it, I find it in the continuous library. I click it, and it will bring a very basic transfer function for me. I have a first order transfer function with denominator coefficients just 1 and 1. Just to make it slightly interesting, let me change it to something like 156. And that makes this a second order transfer function. Slightly interesting. I can simply bring it and join it to the scope block if I'm still interested to monitor this signal, which I am, and change this to plant. And you see this line is intersecting with the plant I just created, so I can simply click that signal and auto route it. So that will take care of not intersecting with the blocks. Okay, so now for the plant model, let's bring a PID controller. Again, search for it. It's available with the continuous library. Just bring it in and plug it in between the source and the plant. You can see how the signal connections are pretty straightforward. Simulink is smart enough to understand that if it is aligned with the right ports, you might want a connection, and it would just create a connection for you.
Now, one thing I would do with that signal that goes from the sine waves to the scope, I would actually drag it below, right? Just a little bit cleaner.
Yeah, you can. Yeah, you are free to move the signals around, but you can also let Simulink auto route it according to the algorithm for best optimization.
Yeah, so you can adjust it however you want.
Exactly. So once we are done with that, this is still an open loop control. You can run the simulation at this point and just see how it looks like. And also the other thing is we are using sine wave, and that's probably not the right one.
Oh, yeah, sine wave's not a very good impulse because it's tough to really track what's going on.
You can't say whether you're
is that a good controller? I don't know.
Right.
So probably a step input.
Yeah.
Is better.
Yeah. So let me delete the sine wave and bring in a step block from sources library. Yeah. The default value is 1, so I'll leave the step time as 1 and just join it back to my model.
Okay.
And let's run the simulation now. It's still open loop control, but
so not very good because blue is the reference, and then that's not the best response. Right?
Yeah.
So so we want to have a closed loop system instead. I would imagine.
Yeah. So I'll bring a sum block. I'm sorry. I bring a sum block here.
Okay.
And
with the intention of you're going to take the error here. So
I just look at the difference between the input and the output, and so that the control signal is appropriately sent from the controller to the plant.
Okay.
So once I hit that, it changed the sign to minus.
Yeah.
I would like to just drag it here, but since there are multiple ports, it would just not join it because it doesn't know which port to join it to.
So in this case, you actually have to sever the connection there. But
it's not that difficult. Just add it, move the blocks out a little bit if you'd like, and then take the signal back and connect it to the plant.
Okay.
Can bring that signal down here as well. Now this looks pretty neat.
Yeah, now it's closed loop.
Yeah, and see how the controller behaves now.
Well, that's better.
Yeah.
I still wouldn't say that that's perfect or ideal or.
Right.
Yeah, we could do better than that.
Yes, for sure. Before getting into making the controller better, I would like to focus on some of the other signal visualization features.
Sure.
So that we can have a better view of signals when we are tuning the controller.
Okay.
So one thing I want to show is the fact that instead of having a separate block outside of the Simulink model, like the scope block for visualizing signals, I would like to show this other block that we have, which is called dashboard scope. It's also similar to scope block, but by bringing that block in within Simulink, it just becomes a part of the canvas. The scope just becomes a part of this canvas, and I can double click that block and connect the signals that I would want to monitor, the signal and the input signal.
Okay, so this way you don't have to well, let's see, right? You press OK.
Yeah.
Run the simulation. Right.
Yeah.
So this way, you don't have to open up the scope block in order to see the results. You can see the results directly in the canvas.
Exactly.
Itself, right. So, so I guess what I'd say about this is you have the option of what you want to do, because some people might look at this and say, well, this is great. I always want to see the results directly on the model itself. But you got to realize that's taking up some real estate on your model. And yes, for our simple model here, that's fine.
Yeah.
But your models are eventually going to get larger. So having the scope block as kind of a small way to get into it is another way to go. So it really depends on your preference and the type of model that you're working with.
Yeah. And definitely scope block does have some other benefits. Like if I just click the stepping options and enable stepping back and choose the stepping back here by any number of steps, I'm just choosing 50. And I can pause my I can actually ask Simulink to pause my simulation when the time reaches 5. And that way, basically, first of all, I can run my simulation directly from the scope block. So if I'm done with my modeling and I'm in my analysis mode, I can just use my scope block, which is something you cannot do with the dashboard block, but you can simply run. And you see that signal gets paused.
Oh, yeah.
Yeah. And in this case, you can use other things like cursor measurements, and that will bring in the cursor measurements that you want to analyze that signal and so on. It's useful when you are just doing signal analysis and there is an interesting data point that you want to analyze.
Okay.
But if you are not into analysis, still in the design or exploratory mode, you can still use the canvas, use the dashboard block. It also pauses.
What if you have a signal, like, okay, so you hover on a signal that's not currently being scoped. If you click on it, you could actually see the current value of the signal when you run the simulation.
Yeah.
So like step forward or advance.
Yeah, I just paused my simulation.
Yeah.
So I can actually use a step forward, like you said, and step forward each time step or go back in time. That way, you can look at how this value is changing at every event.
Yeah, yeah. So that's great. So that's used for as a debugging tool.
Right.
Now our simulation is only going for 10 seconds. So,
right.
If it were longer, maybe that would have a few more steps. But
exactly.
Actually, we could change that, right? So if we change that to like 30 seconds.
Yes, we can do that.
There.
Yeah. And
play.
Right now we are in the previous simulation, so this value might not affect.
Yeah, so that's true. So if you press play now,
it will again pause at 5 seconds.
Yeah.
And if I do a step forward.
Okay, so maybe if you stop it.
Right. And
go back into the stepping parameters here. Change the move back and forward to say 10.
Yeah, and that's
maybe that was too many.
Bigger steps. Yeah.
All right, now
if I run and pause it and do a step forward. Yeah. Okay. So it just goes by 10 steps.
And can you re-highlight the signal, because then people can see. Yeah. Okay. So the signal is changing each time you go through.
Yes.
So nice little debugging.
Yeah, you can basically visually see and monitor what's going on here.
Yeah, it's like adding a watch to a variable.
Yeah.
Familiar with that?
Yeah.
Okay, great.
So let me disable that, stop the simulation, maybe move this back to 10 seconds, and run my simulation one last time. Okay, let me disable the pause as well.
Yeah.
The reason I want to do that is I want to get all the data, and then once I tune my controller, I want to be able to compare between these two. And the way to do that is actually using this badge.
Yeah, so this badge automatically got added to the signal when you added that dashboard scope.
Yes, exactly. So when I double click it, it will open the simulation data inspector. But it would have several runs already showing here, because after I added the dashboard scope block, I have run my model several times.
Yeah, so each time you run a simulation, it's storing that data within this simulation data inspector.
Yeah. Let's start tuning the PID controller, for example, so that we get better steady state early enough.
So we can change the PID gain values here.
Yeah.
Which default are 1, 1, and 0. So I don't know. What do you think?
We can either manually do it. Yeah, we can manually try doing it, but like Michael suggested, I just inserted 5, 5, 5 for each of the gains. And if I ran my simulation, it's better than the previous.
Yeah, that's better.
Yeah.
But I bet we could do better.
Yes, it's not the best. So
and we want the best.
Yes, and you might spend some time to find the best possible combination. But I like to use this tune button, which is it invokes a PID tuning tool. It's a part of Simulink Control Design product. And when I click that, it opens up a nice UI where it visually shows me how the signal, how the response should look like.
Okay. So just to be clear, this PID controller block is included in Simulink, but if you want to open up this automated tuning tool that's here, that's available if you have Simulink Control Design.
Exactly. Okay. And as you can see here, the dotted line is what our block is currently doing, and the solid line is how we want our block to perform. And we can adjust those the way that we want the block to perform by moving these slider values up here.
Yeah, let's make it a little faster.
Yeah. So that way it reaches steady state faster.
Okay.
And once we are happy with this response, we can simply click on Update Block. And I think that's the best part of this tuner.
So what is that? That changes the parameters in the block itself, right?
Yes. We had 555. Now it's these values.
I guess we weren't that close, huh?
Yes, which would have been extremely difficult to guess for a specific response that we want to look at.
Yeah, without that tuning button, I would most likely have just kept changing values, pressing OK, pressing play.
Yeah.
And just keep iterating back and forth. So this just makes it easier.
Yeah.
Than doing that.
So once we have that, we can verify that in simulation whether that response is
nice.
Showing in simulation as well for that plant we choose. So that's basically how you would look at tune your controller and look at the results. Now let's go back.
Let's go back to Simulation Data Inspector, right?
Yeah. So we ran the simulation a couple times already. One time we used manual, but this time we use automatic PID. So I'll rename the automatic PID tuning as just a reference for my sake. Yep. And I've compared my baseline using this compare tab, my baseline as the starting point, and I'm going to compare it with the automatic PID tuning that I have done.
Okay.
I can compare these two simulation runs, and it would visually show me how the signals are different and the difference between the values of the signal on the bottom half.
Okay, so for here, it's showing you that clearly we had different response signals between the starting point of 555 and then the automatic, and it's telling you the difference is about 0.9, and you can set a tolerance when you're doing these differences. So by default, it's this 0, which is why you're getting that X over there on the left, because it's out of tolerance.
Right.
So I guess for this example, we expected the results to change. Yeah. So, obviously we're going to be out of tolerance. But I think one of the reasons why people use this comparison tool is, let's say you have a model, you want to look at changing some parameters to maybe optimize the performance, but you don't want the actual results to change.
Right.
And you just want to make sure that the changes that you make don't significantly change the desired response.
Yeah.
You can do this comparison in here and make sure that everything is staying within tolerance. Right?
Yeah, exactly. And these fields are editable. So you can, if you want strict tolerance,
to say 1.
If I change it to 1, this should turn back to, and like run compare again, they should turn green because our difference is only 0.94.
Right.
So
okay,
that's what it is. Like sometimes you just want the output to be same, like Michael just mentioned, and that in that cases you could set a tolerance and check for the results.
Yeah, you can imagine your model, and this is only 2 signals, right?
Yes.
Most likely you're going to be interested in more than 2 signals in your own models, and it'll just track all of those comparisons here in one spot.
In one spot, yeah. And in addition, you can also send these results to MATLAB figures.
Oh, so if you click on that, it'll just open up a MATLAB figure?
Yeah. And I can try doing that. And that would be a MATLAB figure. Here you can basically add additional information like titles and so on.
Sure.
And I don't know. I mean, you can do additional data manipulations right here.
It's nice being able to go from this tool to MATLAB figure because a lot of people are used to working with MATLAB figures.
Exactly.
So
yeah,
whatever you're comfortable with.
Yeah. Instead of pulling the simulation data and then plotting it on by yourself, right? You can create figures from here.
So what if you do want to store all this data, though? It's pretty easy to do that, I think.
Yeah. So you can save this data right from the menu items here, and oops, it's just creating multiple windows because it's loading, I guess. And so I can create comparison data mat file. It's stored as a mat file.
Mm-hmm.
And as you can see, this now becomes a mat file which is being represented within Simulation Data Inspector. So when I close MATLAB, come back tomorrow and want to continue with my analysis, I can simply load that mat file using the Simulation Data Inspector, and then I'll be able to compare those.
Yeah. And what's nice, it also showed the same views that you were looking at before. So it'll open it up in the exact spot that you're in the last time. So you can literally continue from where you left off.
Exactly. So that's the benefit of Simulation Data Inspector. It goes one step beyond visualizing. It helps you compare and do additional analysis right from the UI itself.
Tad noslēgumā es jums parādīšu dažus Simulink veidotus modeļus, kā šo, un jūs varēsiet redzēt, kādus viņus veido, cik sarežģīti viņi izskatās un kādi viņi ir. Tātad skatāmies. Tātad šis ir pats pēdējais modelis, ko es vēlējos parādīt. Mana prezentācija ir beigusies. Paldies par uzmanību!